Today we investigate properties of exponents. So to review, there's two parts of exponents. We have a base, we'll call this b, and then we have the exponent. So we looked at this equation with exponential growth and decay with the value in front. But again, the base is the big number, the exponent is the little one. So let's look at different patterns today and try to find some rules. Step 1, write each product in expanded form and then rewrite it in exponential form. So the first one is 2 to the third power times 2 to the fourth. So here's expanded form, it's writing it out. 2 to the third means 2 times 2 times 2. 2 to the fourth means 2 times 2 times 2 times 2. Then we're going to write it in exponential form. So in exponential form, we just need one base and the exponent. So here the base is 2, and it's to the 7th power. Let's try the next one. The next one we would have 5 x's and we would have 12 x's. So you could expand it by writing it all out. Or another way, the shortcut is we would have the base of x, and then if you look at the exponents, like here, 3 and 4, we could add them together to get the 7. And so for here we could have 5 plus 12 and we could add them together to get 17. Let's try the next one. So again, let's say you didn't know the rule, write it out. So we have 10 squared, which means 10 times 10. 10 to the 5th means 10 5 times. All right, and then if you count how many 10s you have 10 to the 7th power. So the shortcut is if you have the same base, you're going to add the exponents. So to write that out, we say this will equal a to the power of m plus n. So again, same base, if they're being multiplied, you would add the exponents. But if you ever forget any of the rules, just write it out. Well, let's look at another rule. What about division? So we have 4 to the 5th over 4 squared. So if I write that out, I have 5 4s on top. I have 2 4s on the bottom. And we can cancel some things. Any number divided by itself is 1, and we're left with 4 to the 3rd. Let's try the next one. We have 8 x's on top. We have 6 x's on the bottom. How many cancel? Well, 6 of them cancel. So you have 2 left on the top, x squared. Now instead of writing this out, we would have 15.94s on the top and 5 of them on the bottom. So you would think, how many cancel? Well, 5 of them cancel. So to get how many are left on top, it would be 10 left on top. It'd be 0.94 to the 10th power. One way you can get that is you can subtract the exponents. 15 minus 5 is 10. 8 minus 6 is 2. 5 minus 2 is 3. So to generalize, if you have the same base and they're being divided, you can subtract the exponents, a to the m minus n power. All right, let's do that again, but what happens if the number, the exponent, is bigger in the denominator, in the bottom of the fraction? So again, we can write it out. 2 to the 3rd over 2 to the 4th means 2 times 2 times 2. And then we have 4 2's on bottom. And then we can cancel, and we get 1 over 2. Let's try the next one. We have 5 4's on top, 7 on the bottom. If you think about how many cancel, there's 5 that cancel, and we get 1 over 4 squared. How about this one? X to the 3rd over x to the 8. You would think about canceling 3 from top and bottom. If everything cancels from the top, there's a 1 there, and you would have 5 x's left on the bottom. So it says rewrite each quotient in step 5 using the property you discovered in step 4. Well, in step 4, it said you subtract the exponents. So this one will have 2 to the 3 minus 4 power 2 to the negative 1. For this one, we'll have 4 to the 5 over 7 is negative 2. And then the last one, 3 minus 8 is negative 5. So these are actually equivalent. 1 over x to the 5th is the same as x to the negative 5. 1 over 4 squared is the same as 4 to the negative 2. And 1/2 is the same as 2 to the negative 1. So to generalize, 1 over a to the n is the same as a to the negative n. So if you flip the location, you can change the sign of the exponent. So if I had 7 to the negative 3, that's the same as 1 over 7 to the positive 3. Okay, next rule. How about a times n to the m? Let's just make one up here. So let's say I had 2 to the third power to the fourth power. So this one, we could write this out as 2 to the third times 2 to the third times 2 to the third times 2 to the third. From rule number 1, we know we can add the exponents if it has the same base and it's being multiplied. So this is 2 to the 12th. Well, what's a faster way to get the 12? We can multiply 3 times 4 to get the 12. So if you have a to the n power to the m power, you multiply these, and we get a to the n m. Let's do another example. Let's do 7 to the 5th power squared. Again, you could write this out, 7 to the 5th times 7 to the 5th, or you could, and that would equal 7 to the 10th, or you could just multiply. 5 times 2 is 10. So a power to a power, you multiply. What about if it has more than one base? So let's say we had 2 to the third power times 4 to the first power. And we're going to do this twice, squared. So if we write it out, this is 2 to the third times 4 times 2 to the third times 4. Well, if we look at just the same bases, this is 2 to the 6th power, and then the 4s, there's 2 of them. Another way we could get this is just distribute and multiply. 3 times 2 is 6. 2 times 1 is 2. Let's do another example of that. So let's say we had x to the third power, y to the fourth power squared. Again, you could write it out, or we could just distribute. We would get x to the 6th power, y to the 8th power. Let's do another one. How about x, y to the 8th? And we'll do that 4 times. Again, distribute. If there's not an exponent, the exponent's 1. So this is x to the 4th, y to the 32nd. Okay, last rule. Show that a to the 0 equals 1 using the properties you discovered. Write at least 2 exponential expressions to support your explanation. So anything to the 0 power is 1. If you type that in your calculator, like 500 to the 0 power, it will be 1. Here's why. Let's say we have a to the third power over a to the third power. Any number divided by itself is 1. Now if we go back to the rule, if it's division, you subtract the exponents. So this is a to the 3 minus 3 power, which is a to the 0 power. So these two are equal because it comes from multiplying or dividing the same number by itself. Let's do another example. X to the 4th over x to the 4th equals x to the 4 minus 4 will be x to the 0. And we know that any number divided by itself is 1. So anything to the 0 power is 1. So today in your assignment, you're going to just start practicing these rules of exponents, and tomorrow we'll review these and try a few more.